You know, we hear about it all the time, this constant headache of trying to push ultra high-res video over network infrastructure that's, well, let's just say budget friendly. It's a real problem. Today we're diving deep into one piece of hardware that claims to have a very clever solution. It's the Aurora VPX-UC1-ULTRA transceiver. And our mission here isn't just to, read off spec sheet. We're going to try and figure out how audio video over IP AVoIP is really evolving. Because this box, it's more than a transceiver, it's a whole unified communication platform.
Exactly. I mean, the core challenge has always been getting that perfect 4K 60 video with full 4.4.4 color over a standard 1 gigabit network.
You're right.
Historically, you had to make a choice. You either sacrificed quality or you dealt with unacceptable lag. This device claims you don't have to choose anymore.
Okay, so let's get right into it. How did they solve that? Is the magic all in their compression tech, this new MEMX codec?
It absolutely is. This isn't about just raw power. It's about being smart. The MEMX codec, you can think of it as an algorithm that knows what to protect. It keeps text and graphics super sharp while, efficiently handling the motion.
And that results in better performance metrics.
Way better. They're claiming something they call zero frame latency. And they're really specific about it. They quantify it at 1.78 milliseconds.
1.78? Wow. Okay, that sounds impressively low, but what does that actually mean for someone installing this?
It means it's faster than the human eye can see. It feels like a direct cable. It solves that mouse lag problem that used to drive people crazy.
Oh.
You combine that with seamless switching, and all those visual glitches you'd see in older systems are just gone. And the best part, it's all happening over standard CA5E.
So the infrastructure is already there, and they're not skimping on quality to get that speed. I'm seeing HDMI 2.0B, HDCP 2.2, all the HDR formats, HDR10, Dolby Vision.
They didn't sacrifice fidelity for speed. That's the key.
So that's the signal delivery solved. Let's pivot to what I think is the most surprising part. This thing has an actual computer inside. An 8-core ARM processor running Android 12. Why?
That's the part that completely changes the game, right? Because traditionally, these boxes were just, dumb transmitters. Now, you have a powerful, fully functioning computer right there at the endpoint. And that NPU, the neural processing unit, that's for edge processing. It can run AI tasks on its own without calling home to a central server.
So you could run an app directly on the box itself.
Any Android app. Think Zoom, think Teams, maybe a custom room scheduling app. You can run that and blend its video output directly with the video stream coming in. It just becomes another source.
That's a huge shift. So it's an edge server with 32 gigs of flash, 4 gigs of RAM, and you can even add a 1 TB SSD.
It's a dedicated computer, absolutely.
And looking at the connectivity, it seems like they're really thinking about the future here.
Oh, absolutely. You've got dual HDMI outputs.
Right, and they're supporting up to 8K 60. That's next-gen stuff.
Exactly. Using the latest standards to HDMI 2.1, HDCP 2.3, it's ready for those high-end dual-display collaboration rooms. And the audio is just as robust. We're talking 12-channel LPCM, Dolby True HD, even ATMS.
And for networking?
You get a 2.5G LAN port with PoE plus PerC, which is great, and also a 1G SFP port. So you have the option for fiber or even a second copper connection. It's very flexible.
Plus all the enterprise security features you'd expect, like AES 256 encryption. It's even TAA compliant.
They've ticked all the boxes for professional and government use.
So when you put it all together, what are we really looking at? This isn't just a simple box anymore. It's basically a signal converter that grew a brain, a powerful one.
That's a great way to put it. It's an application server at the edge that also handles flawless, zero-latency 4K streaming over the network you already have. Which leaves you with a really interesting question to think about. Given that these endpoints can now run powerful custom software, how does a product like this challenge our old ideas about AV infrastructure? Are we moving away from massive centralized systems toward a smarter, decentralized model where the intelligence lives at the edge? Something to consider.